Hey, what's up, folks? Wanted to show you guys a really cool project that, I guess it's kind of a project that I'm starting, but is evolving into a project that I'm working on. It's involved with having to do with a lot of the network programmability stuff that I've been looking into rather heavily these last couple months. And one of those things that I have been trying to figure out for myself is, understanding where the concepts of SDN can play within a network. And upon some of the things that I've been discovering, that I see that the powerful use for it is not practical. And the more powerful use for it is that if you have a network built from scratch that has the SDN in mind, SDN concepts are way easier to implement. But let's face it, majority of the networks that are out today aren't like that, and a lot of people aren't gonna halt or keep any production going down, or keep any production from happening, in the likes of migrating to this new architecture, even though it could be worth it in the end. Um, to not have anything tangible to make those moves is very difficult. So a lot of the times you end up in these hybrid environments where you're running a space of your network with SDN, but the rest of it is still very traditional management SNMP style stuff that we've been doing. Um, Now, with that said, I mean, and like to use for example the Cisco APIC, the data center stuff that Cisco's been doing. Mind you, they have been kind of gearing towards getting their Nexus equipment to kind of replace the Catalyst stuff, because of the programmability in the Nexus. It's becoming a bigger pitch for them to utilize your core and your distribution layer, with the Nexus switches because of those functionalities. But a lot of the times it's going to be sold mainly for the data center top of rack switch deployment scenarios. But now with that said, with SDN, especially with network devices, the most difficult thing with network devices is the lack of API support. And if you don't know what an API is, that is essentially a interface where an application developer can write his program to talk with, and it can extract and provide data to this API in order to do really cool things. So a lot of these softwares that you see running are utilizing APIs in the back end to communicate with each other. It just makes it a lot easier for developers to do really cool stuff. So in the networking world, because it's always been I'm in my world, I'm Cisco, you can't do what I'm doing type of deal. Even though they're implementing standards for the most part, it was very in the box development when it comes to, developer tool sets. It was very vendor driven. When the with the evolution of open source, um, that kind of kills us because that's what SDN, a lot of the stuff is built off of, is open source concepts. So vendors necessarily weren't building that into play. Some were better than others, like Juniper is a lot better. Juniper and HP is a lot better on the SDN side, and being able to implement some protocols than like say Cisco did. But it's very hit or miss. That's the point. So a lot of the times for the networkers, whenever we have to do any automation task, a lot of the times it's screen scraping activities, which is not reliable. It relies heavily on an expect type of deal, or regex, which regex is still very powerful. Don't get me wrong. It could be an extra character that can throw off your whole regex search depending on how you have it set up. So and plus, if you have anything that happened to your data in transit, because there's no reliability with a lot of these communication packets that, or these a lot of communication methods that we use for transaction data, um, it is very easy to get corrupted data back, with the screen scraping methods that we do for writing scripts. So our scripts aren't necessarily intelligent; they're very sequential, for the most part. We try to make it as flexible as possible, but there's only so much you can do with that type of methodology, especially when you're dealing in multi-vendor environments. So that was the spill, kind of the history and what kind of drawn me into this. So one of the things that I started looking around is seeing, you know, how can I talk to multiple devices without having to talk to multiple devices? And we have monitoring systems like SolarWinds or your Nagios, or whatever of your favorite NMS that you use, that talks to your devices already. So if there was a way that I can tap into that, that would be perfect. Well, come to find out, some vendors, and mind you, this is not me not coming from a developer background. I'm a network engineer by trade, but I've been doing a lot of development, and so one of the things that I didn't realize that's kind of been in the industry on the developer side is something called REST APIs. And now what REST APIs do is that they allow data to be exposed through a series of HTTP calls. So that way you can do state and transactional data from server to server over a network protocol. But it's going to be an HTTP get, put, a delete request, post request too as well, that you can do. So that's one of the cool things about REST APIs. So a lot of these vendors have these REST APIs, but because once again the development is so in-house, and I'm sure you can contribute, a lot of it is in-house. Some of the data that you may particularly want is not there, or may not be there, or may not be documented well enough to where it's as easy as it should be to get a specific set of data. And plus you got to have a lot of these companies are realizing that people want this functionality because and at the end of the day it helps generate more revenue, and if that's the case they want their cut too. So you're not going to get the community or free versions that allow you to do a lot of API doc development stuff. You're going to really only get that with a lot of pro versions of these different NMS software. So that was a big thing on my end for an active developer who needs something to be flexible in my lab. I didn't have that, so I went ahead and started just looking around and realizing that, well, and so kind of going back on the screen scraping thing as well. Um, I had two problems here. I needed a way to talk to many devices, and then I needed a way to receive and talk to multiple devices the same way. So if I go from Juniper, Brocade, whatever the case is, it doesn't matter. I should be able to send one single call out and get one state of information back, regardless of whatever the device is. Well, um, knowing that we already have something called SNMP, because and a lot of people don't know SNMP, the original purpose was to use it for actual network configuration as well, but it never really made it into that realm, especially on the operations side. But that was kind of the purpose of it. So I started looking deeper into SNMP and realizing that SNMP is standardized very heavily in the MIB tree, and so there's certain things that you can gather that will be the same no matter what device you're talking to, and it's pretty big things, especially some of the protocol standards, especially some of the pertinent device information, serial numbers, host names, interfaces, interface IP addresses, bandwidth statements, MTUs. A lot of the information that you normally would be you would try to screen scribe doing an SSH session, you could pull directly with SNMP. So I went ahead and wrote a script. Wrote a couple scripts, but I'll walk through what I started here first. So I wrote a script called Connector, and so this project is an overall project that I'm working on. But part of it is I created a class called Connector, and what that does is it instantiates an object that is a SNMP client. So what ends up happening is once I instantiate this object within my snap script, I will go ahead and create multiple nodes using that connector class. And so what I also did was after creating the connector class, I decided to create a REST API. And so what I'm doing with this is that essentially all the information that I have my connector gathering, and right now it's only two main methods that I have it doing. I have it doing a get link, so it gets all the interface information, and then I have it do a get sys information, and what that does is it grabs all the system information from the actual devices, and then I have it outputting it into a JSON format. But because I don't have an active database running, I needed something to mimic a database of multiple devices. So this snap, I have devices that are actually configured in my house, like my Plex server, my QNAP router, my QNAP NAS, a couple other VMs, Juniper and Nexus 1000 Vs, or not Nexus 1000 Vs, with the NXOS Titanium. I have a couple of VMs running that all these hosts are aggregated into this list. And so what this is going to do is I'm actually going to go ahead and simulate me doing generating a database, and then my RESTful API will actually abstract the information that I generated with this snap script and then present it in the web browser. So the way that works is that all I gotta go do is, because I'm running it on my Mac locally, I'm just gonna go through and just go to 188 devices. So when I go to this URL, it's actually running in the background. So in the background, because I don't have it talking to a device and to a database, and it's not readily available, um, this is actually actively going through and grabbing all the device information, abstracting it, and then it should be displaying it here. Yep, and it just got finished here. So it would be a lot faster if I have it pulling it from the database, because it's actually logging into the device every single time I hit refresh. It's going to take a little second to populate. But as you can see, so this is what's the beautiful thing about REST APIs is that I can do all the hard work on the back end of my server, have it extract and normalize the data that I want, and at that point, any application that I use to write into interact with it, I'm actually interacting with a dictionary, a Python dictionary of the information that I need. And so that way I can actually go through and get pretty granular with some of the applications features that I would want to add. So like I said, this is just the beginning of it. Thought it was pretty cool, because the programmability stuff is just something that I've been really, really, really into. But this is one of the things that I wanted to do, and now I figured out how. But um, yeah, I mean, it's pretty straightforward. What I use to do this with is I use Flask in Python. Well, Flask is a framework, is a web framework that you can use in Python, and it's super easy to get this running. I mean, I'm not going to do anything fancy as far as all I want it to do. With the REST APIs, it just needs to return information like this. I mean, that's all it is. I don't need it to run a web page. I don't need it to be beautiful. I can write a GUI application for that. But this connector here, or this, what I'm gonna call it, is my snap is what my applications would then interact with, and then I can be able to pull state data. And then one of the things to show you, so like this is a Cisco device. I know I have. Let me see if I have Juniper on here. Yeah. So I have a Juniper there for the vendor, and then yeah, Synology, and my Linux. So like I said, it's got a pretty cool. It's pretty basic right now, but essentially once it's done, I'll build in some SNMP v3 support. Right now, it's only doing v2, but hopefully this will, you know, project will go on. All right, guys, thanks.